Hello everyone, welcome back to our next video, and as you saw from the title of the video, you know what we are going to talk about. But do you know that we can see the sun even after sunset and even before the sunrise? Well, if you want to know how, then make sure you watch the video till the end, and without wasting any more time, let's dive in directly into today's topic. So our first question is, why do stars twinkle? And twinkling of stars is associated completely with atmospheric refraction. Now we need to understand what is atmospheric refraction. We all know that light refracts when it moves from one medium to the other medium, and if there is change in density. That means if light moves from a denser medium to a rarer medium, then there is going to be refraction, and the vice versa, that is from rarer to denser. So suppose we have two medium, this is the rarer medium and this is the denser medium. What happens is when light comes from rarer medium to a denser medium, it will bend towards the normal. We all know about this. And when light moves from a denser to a rarer medium, then what happens? If we draw the normal, then light comes in light will come in and it will bend away from the normal. So if this is the light, then instead of moving like this, it will move away from the normal. So these are things that we have studied earlier, and we know that that refraction takes place like this. Now, why does atmosphere show this type of property? That is the question. Now, atmosphere, our atmosphere or any atmosphere of any planet for that matter, has a different layers of atmosphere. That means we have different properties of different layers where the composition is different as well as the density is different. So what happens in the case of Earth is that if we consider a flat surface, suppose this is one surface of the Earth, and here an observer is standing. Now what the thing is going to be that the composition of the atmosphere is never constant. It keeps on changing because of various factors like heat, moisture, humidity, etc. So what we have first of all is different layers of atmosphere. So we'll have one layer here, second layer here, third layer, and many different layers keep on adding up. Okay? So as the layers keep on adding up and each have a different density, and generally what happens is density keeps on increasing as we come down. We all know that level of air becomes very less, the composition of air becomes very less as we go higher up in the atmosphere. So if you go above Mount Everest, the amount of air you are going to find there is going to be very less compared to the air you are going to find at a plane surface. So as we go up, the concentration of our atmosphere decreases. So what happens is, as we move down, we are always moving from a rarer medium to a denser medium. That means the light that will come in will always be going to be bending towards the normal. So let us not take so many layers, let us take a few layers for our example. Suppose we have 1, 2, 3, and that is the fourth layer. So suppose here is the star that we are going to discuss about. Now in case of this star, what happens is light will be coming from here and trying to reach the observer. What happens is, suppose the light comes in this direction. Okay, now what will happen? The light will start bending towards the normal. Another layer and again towards the normal. Another layer and again towards the normal, and it has reached the observer. Now according to the observer, if I trace back this light, then what I will find is star appears to be here. Where the real fact is the star is actually here, but because of this atmospheric refraction, the light has bent to the observer, and for the observer the virtual position of the star does not anymore seem here, rather it moves to this portion. And not only that, as the composition of the atmosphere keeps on changing, that means the density of this will also keep on changing. And as this density changes, this bending of light, the amount of bending will also keep on changing. And as the amount of bending keeps on changing, this position will also flicker after every few minutes or every few seconds. And that is why we say that the stars seem to flicker or the stars seem to twinkle, and that's why the twinkle twinkle little stars. So that's what we have here. Let me go on and repeat it for you once again. As the density of the atmospheric layers become more and more as we come down towards the earth, when the light will be coming from the stars in this direction, to start bending towards the normal. So it will be always coming closer to the normal and up to the observer. Now for the observer, the light is not coming from this point, rather if we trace the light back, it moves somewhere to this point. For him, the star is here and not here. So first of all, an observer can never see the star in its original position until and unless the star is directly above the person's head. If the star is directly above a person's head, in that case, the light is going to hit the different layers of observers at the normal. And if any source of light hits a surface at normal, there is no refraction. I hope you know that if you have a surface, it may be rarer, it may be denser, but if the light hits straight at a 90-degree angle, then it will move straight as well, it will never bend. So until and unless the star is exactly over your head, 90 degree over your head, only those stars you can see at their correct position. Any other star which is just less or more than 90 degree above your head, those stars you can never see at their original position, and you will always see them away from their original position. And in addition to that, as the atmospheric concentration keeps on changing every now and then because of various factors, these densities will also keep on changing, and as a result, the amount of refraction will also keep on changing. If the amount of refraction changes, suppose in another case, the refraction occurs in this way, the refraction is a bit more here comes the position, and then here comes the position, and then here, then for this time, star will seem to be here. So no more the star will be here, the star will be here. Maybe this may happen in every 20 seconds, or maybe after every 10 seconds. So at 1 second you will see it here, after 10 seconds you are seeing the star here. That is why we say that the position of stars flicker and the stars twinkle. So that was about the first part of the video. Let's move into the question that I asked you at the introduction part of the video, that we can see the sun before the sunrise and after the sunset as well, and let's see how does that happen. So what I am going to do here is I am going to draw a rough diagram of the earth. So suppose this is our earth and we have a layer of atmosphere. Now I am not going to draw too many layers, let's draw just one layer to get the idea. And here you are standing and you think that the sun is about to set. What you observe here is, for you, this is the level of your horizon. So this is your horizon, and you feel when the sun has already set, this is our sun. When the sun has already set, now from in which direction do you think the light of the sun will go? The sun's light will be moving towards this direction. Okay, so this is going to be the direction of the sun's light. But the thing is, as the sun hits the atmosphere, so this is the rarer medium and this is the denser medium. So what happens now? Let me rub this part and let me show you in a fresh manner. When the sun's light hits the atmosphere, at that time it will start bending towards the normal. So instead of taking its straight path, what will happen is it will start bending and reach the observer's eye. And for the observer, at that point of time, the sun will seem to be at this position. Hope you can get the idea. When the sun has already set, the light needs to move straight, but as it hits the atmosphere, its path changes. So rather than going in a straight line, it will bend towards the normal, and as it keeps bending, when it reaches your eye, you think, just like in case of stars, that the sun is is already above the horizon and it is yet to set. And the same thing happens during sunrise. When the sun is about to rise, when it is still below the horizon, we think the sun has already risen because of this atmospheric reflection. So when it is just below the horizon, at that point of time we can see the sunrise, and even after the sunset, the sun has already set and we can see the beautiful red sun. It's still the case that sun has already set, and what we are seeing is actually a virtual position of the sun. That is a beautiful part of physics, where we see light playing around with us and we cannot even understand in a general case that what is really happening. Have you ever thought that the sun that you see just minutes before sunset is not actually the sun at that position? The position of the sun is actually a different position and the sun has already set. Have you ever thought that the stars that you see at night every single day are not even present there? They may be present light years away from you. Since the distance is so long, we can see the stars right above our head. So That is the beauty of physics and that is the beauty of science. So if you enjoyed the video, if you liked today's video, then make sure to click on the like button. Share the video with your friends if you think they can find something beneficial from here as well. Thank you everyone for watching, and until next time,